are going to see cyclomatic complexity. What is a cyclomatic complexity? It is a software metric used for structured or white box testing to evaluate the complexity of the program. And it is a quantitative measure of independent paths in the source code. We can calculate the number of independent paths in the source code so that a software tester can test all the independent paths. An independent path is defined as a path that has at least one edge which has not been traversed before in any other paths. And this cyclomatic complexity can be calculated by using control flow graphs. And this was developed by Thomas J. McCabe in 1976. The control flow graph. Any procedural design can be translated into a control flow graph. Circles are called as nodes. They represent one or more actions. Lines are called as edges. They represent flow of control. Areas bounded by edges and nodes are called as regions. And a predicate node is a node containing a condition. This predicate node can have more than one edges emanating from it. Here some examples of basic control flow graph structure. For straight line code, this is the control flow graph structure. For if then else, for looping constructors, and for switch case. So these are all some basic control flow graph structures. By using this control flow structures, how to calculate cyclomatic complexity? There are three different ways to calculate V of G. V of G is equal to number of edges minus nodes plus 2. And the second formula, V of G is equal to number of regions in the control flow graph. And third one, V of G is equal to number of predicate nodes plus 1. So here the example goes. Number 1, first example, and code is given, control flow graph, and third one is cyclomatic complexity is also given. So all the statements in the code part is converted into control flow graph. So there are 7 statements, so 7 nodes are there, and here the edges, number of edges are also 7. So by using the first formula, V of G, so these 7 nodes and 7 edges, so 7 minus 7 plus 2 is equal to 2. And next one is number of regions. So you have one inner region and one outer region. So V of G is equal to 2. And the third formula, number of predicate nodes plus 1. Only one predicate node. So 1 plus 1 is equal to 2. But in the next example, consider this. So here for formula 1 and 2 gives, they give the same number 3 as a cyclomatic complexity. But the third one gives a wrong answer because here there is a limitation on the predicate node formula. Here the predicate node 3 has 3 emanating edges, 4, 5, 6. So here P plus 1 will give you 1 plus 1 is equal to 2. So in order to adjust this, we have to split the predicate nodes into 2 subnodes so that we can have the correct answer. And here the complexity number and corresponding meaning is given in the table. For example, if the complexity number is from 1 to 10, your code is a structured and well written code and it has high testability and the cost and effort is also very less. So similarly for other complexity number criteria, the range is given and the meaning is also given. And next, the uses of cyclomatic complexity. As you know, this is very much used for the software developers and testers to determine the number of independent path execution, and it can assure all the paths that have been tested at least once, and it helps to focus more on the uncovered paths, and this is used to evaluate the risk associated with the application or program. Once you find the number of independent path executions, you can test your software. So for that, the cyclomatic complexity is used. Hope you would have all enjoyed this session. Thank you very much.